All right, let's talk about the central limit theorem. So when we select a random sample from a population, the sampling distribution, the sample mean, can be approximated by a normal distribution as the sample size becomes larger. So remember, if our data are normally distributed, we can more easily calculate probabilities. So in this chapter and in previous chapter, we've learned how to use the standard normal to calculate probabilities. So that's why it's important to understand what a population, how it's distributed, because that will help us better understand how to calculate probabilities. So if our population is normally distributed, the sampling distribution is normally distributed for any sample size. So if we're told, or if we know that the population is normally distributed, right, we can assume the sampling distribution is normally distributed. And again, we really care about the sampling distribution because that's what we use to calculate our probabilities. If the population is not normally distributed, or if we don't know, we can assume that the sampling distribution will approach a normal distribution as the sample size increases, specifically as it approaches 30, 50, and above. But still, this isn't always the case. Where do these numbers come from? It is best just to plot your data, see how they're distributed, because otherwise, if you have problems with your distribution, that's going to affect your probabilities, and it's therefore going to affect the conclusions that you come to. So let's just make this clear. Let's look at a picture of what I'm trying to say. So if you have different populations that are not normally distributed, right? So this is uniform, this is called the bunny ears, this is an exponential distribution. These are the sampling distributions and what they look like at various sample sizes. So this is sample size 2, 5, and 30. So you can see as the sample size increases, the sampling distribution approaches a normal distribution. So that's all the central limit theorem says, that as your sample size gets larger, specifically as it gets to 30, 50, and above, it approaches a normal distribution, which will help us calculate our probabilities.